Hello everyone, welcome back on our YouTube channel Physics Made Easy Kota. In this video lecture, we are going to learn about the important concepts related to the chapter of the class plus 2 physics. I am Daljit Kaur welcoming you in our next video lecture of the chapter atoms and nuclei, and this is the third part of this chapter. In this chapter, we are going to talk about the nucleus and some other important concepts. We already learned about the atoms. Now what is nucleus? An atom consists of the central region which is called as the nucleus, and it is always positively charged. It is positively charged due to the presence of the positively charged particle called protons, and it also consists of the neutral particles called neutrons. Most of the mass, we can say about 99.9% of the atom is concentrated in the nucleus of the atom. The radius of the nucleus is smaller than the radius of the atom by the factor of 10 raised to power 4, and the volume of the nucleus is nearly 10 raised to power minus 12th of the volume of the atom. To understand about the composition of the nucleus, we must know about the atomic mass unit. Atomic mass unit is the unit in which we can express the mass of the nucleus and its constituent particles, and this is one of the smallest unit. We can use the different symbols for this, like we can use a symbol U that represent the unified mass unit. Also another symbol can be used, that is AMU, which means atomic mass unit. In actual, atomic mass unit is defined as the 1/12th of the mass of the carbon atom. We can compare it with the mass of the carbon atom. We know that 1 mole of the carbon atom has a mass of the 12 gram, and the 1 mole of a carbon atom contains 6.022 into 10 raised to power 23 atoms. So the mass of all these atoms of the carbon, that is the mass of 6.022 into 10 raised to power 23 atoms of the carbon, is equal to 12 gram, and we can calculate the mass of the one atom of the carbon by taking the terms 12 divided by the 6.022 into 10 raised to power 23 gram. After division, we get the answer 1.66 into 10 raised to power minus 24 gram. We can also express it in term of the kg. It is equal to 1.66 into 10 raised to power minus 27 kg. Now for the energy equivalent to 1 AMU, to express the energy in the AMU, we take the Einstein mass energy equation, that is E is equal to mc square. Take mass is equal to 1 AMU, and we know that 1 AMU is equal to 1.66 into 10 raised to power minus 27 kg, that we had done earlier in this video, and where c means the velocity of light in vacuum, and its value is equal to 3 into 10 raised to power 8 meter per second. Now put the value of the mass as well as the velocity in the relation E is equal to mc square. After calculation, we get the answer 1.49 into 10 raised to power minus 10 joule. This answer is expressed in joule. To convert it into the higher unit, mega electron volt, divided by the 1.6 into 10 raised to power minus 13. So after that, we get the final answer, that is 931.25 mega electron volt. Hence 1 AMU is expressed as 931 mega electron volt approximately. Rutherford performed the experiment, and his experiment suggests the existence of some positively charged region within the atom, and that is known as the nucleus. Almost all the mass of the atom is concentrated within this small volume of atom, but in the beginning, in the initial stages, nucleus was assumed to contain protons and electrons. However, later on it was established that electrons cannot exist inside the nucleus, and the discovery of the neutron take place, which proved that the nucleus is composed of protons and neutrons, and electrons are orbiting outside the nucleus in the electron shell. Then the neutrons and the protons together known as the nucleons. Here is a capital X which represent an element. So we can take X is the symbol of the element. We can take any element, for example carbon, sodium, any element. Here there is capital A and capital Z. Capital Z is a subscript and capital A is a superscript. Capital Z is the atomic number of the element. Capital A is the mass number of the element. So what is atomic number? Atomic number is always denoted by capital Z. It is the number of the protons present in the nucleus of an atom, whereas mass number is denoted by capital A. It is a number of the protons plus number of the neutrons, and both these symbols are drawn with the symbol of the element, so they represent the symbolic or atomic symbol of any element. We can take the example of the carbon. Carbon 12 6. 6 shows the atomic number, which means that the number of the protons. And to calculate the mass number, we can apply the formula that is equal to the number of protons plus number of neutrons. So this is the symbolic representation to express any element. For example, helium. Symbol is He. H is in a capital letter and E is in a small format. Its atomic number is 2, which means that the number of protons are 2. Number of protons are always equal to the number of the electrons. So number of the electrons are also is equal to 2. Whereas the atomic mass of helium is 4. So to find the number of the neutrons, we can apply the formula of the mass number is equal to protons plus neutrons. We are aware about the mass number, that is equal to 4. So 4 is equal to protons are 2 plus neutrons. On solving, we get the number of the neutrons, that is 4 minus 2 is equal to 2 is equal to number of neutrons present in helium atom. You already listened these words isotopes, isobars and isotones. Now we are going to understand them one by one. So first of all is isotopes. This is a Greek word which means same place. So the atoms of a particular chemical element have same atomic number by different mass number. Isotopes have same number of electrons and protons but different number of neutrons. They occupy the same position in the periodic table. Next are isobars. The atoms of different chemical element have same mass number but different atomic number. Isobars have same number of total nucleons but different number of protons, electrons and atom. Isobars appear at different places in the periodic table. They have different chemical and physical properties. Next are the isotones. The atoms of different chemical elements having the same number of neutrons but different atomic numbers are known as isotones. How we come to know the difference between the isotope, isobars and isotones? These examples help us to specify which one are the isotopes and which one are the rest of the isotones or isobars. For the isotopes, they have the same atomic number and they have the different atomic mass. For the isobars, they have the same atomic mass and they have the different atomic number. For the isotones, they have the same number of the neutrons and the difference arises in atomic number and masses. We can calculate the number of the neutrons by applying the formula of the atomic mass. So thank you for watching. Take care. Have a nice day.